Hi everyone, let's look into this problem today. It is for merging two sorted arrays and it is problem number 88 on LeetCode and it is an easy problem. It is categorized as an easy problem, but it is a good problem to think out of the box or think differently than the normal way and to learn the basics. So you have given two integer arrays num1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. So the first solution that comes to our mind is using a third array to store the result. Iterate through each elements of both the arrays using 2 pointers and store the result in the final array, and at the end copy the result array into nums1 array. But we can do it in a smarter way without using a third array. So let's look at the first example. So the array contains elements 1, 2, 3, 0, 0, 0 and second array contains 2, 5, 6. If you see the size of nums1 array, it is m plus n. That is because the first array contains space to accommodate elements from second array as well. So the first array is a final array which will be containing elements from both arrays in non-decreasing order. As I said before, the first thing that comes to our mind is to use a third array, but that increases space complexity. So let's see how we can solve it without using a third array in a better way. So these are the two arrays from the first example. And if you look at the first array, there are 3 spaces which are filled with zeros. So we can utilize this space to hold elements in their final position. So one way would be to find the smallest element and start filling from the left position, or to find the biggest element and start filling from the right position. But if you fill from the left position, we will have to do some movements, like move the elements, push the elements to the right. But since we already have empty spaces in the first array, we can utilize those spaces. So we will, instead of finding the smallest element, we will start by finding the biggest element. So we can start it by using 3 pointers. So the green one shows the position where we will be inserting, and the red pointers shows the elements which are being considered at the current iteration. So this is how it will be at the start of the iteration. So when we start, we will see if which element is bigger, 3 or 6. So since 6 is a bigger element, we will move it to this position and we will decrease the counters. So this will be 6 and this green pointer will be moved to this position because this is where we are going to insert the element next. And since 6 is already placed, we can decrease the pointer here. So we will remove the pointer and put it here. In the next iteration, we will compare element 5 and 3, and we see that 5 is bigger, so we will insert 5 in this position. We have to move the pointer because 5 is in final position, and this pointer we have to move here. So next, when we compare 2 and 3, we see that 3 is bigger, so we have to move 3 from this array, this position, to this one. And this next position is going to be this one, where we have to insert, and since we have already placed this element, the first pointer will be decreased by 1. Now 2 and 2. So since both are same, we can insert either of them. So let's say that I decided to insert the element from the second array. So this will be 2, and this pointer will be decreased by 1, and this one will be decreased by 1 as well. So it has gone beyond the boundary of the array. So that is when we stop our iteration and we come out. So if you see here, we have gone through all the elements of second array. So whatever elements are present in nums1 array is our result. And if you see that, it's already in sorted order, because whatever elements that comes left side of this green pointer will be already sorted, as our input array is in sorted order already. So let's see how we can code this. So I have already written the main class. So initially we will start with m plus n minus 1. Excuse me. So this is a final position. Then we have 2 pointers, say so these are our 3 pointers, okay? And now we can use a while loop. So our condition is that both of these arrays should have elements left in it. If one of the array is emptied, then we don't have to loop through it. So we to 0 so next we have to compare the elements. Say so remember, nums1 is our result array, and this is the final position. Okay, so we stored element from the second array to the final position in the nums1 array. Then we have to decrease the counters. So this final position we have to decrease anyway. Else we have to move the element from the first array. So there might be so this is our while loop, and this is the end of while loop. So once we come out of this, there can be a situation where there are still elements in the second array. So if there are still elements in the first array, it is okay, because a result array is a first array. But if there are elements which are left in the second array, we need to copy it. So we have to see if it is greater than or equal to 0. Then we can just do a system array copy. So our source is nums2, then start position will be always 0 and destination is nums1, and the start location would again be the destination location. Then how many elements should be copied? So that would be pointer plus 1. Some boundary conditions we have to handle. So if the second array is 0, so if n equals to 0, we can just return because the result is already in the first array. If m equal to 0, then that means there are no elements in the first array, and we have to just do array copy of second array into the first array. Destination is nums1. So this is our code, and let's run this. Runtime is 0 milliseconds and it is passed both test cases. Let's submit it. So it beats 100% of users with Java, and memory is 42 MB, and it is cleared all the test cases. So that's it. Thank you for watching.